3 to 4 classes exclusively for FP because of the logic and complexity involved in that. Because you recursively get certain trees and how you will be extracting patterns and all. A lot of logic is involved in this. One can really enjoy if you logically go ahead with it. This is the topic wherein you need not mug up anything. You need not mug up anything, but you are supposed to apply your brain and go sequentially. So this is a real beautiful algorithm. But due to shortage of time, I'm only spending couple of hours today on this, but normally I was spending about 8 hours on this algorithm actually before because I was deriving all these steps involved totally, because with reference to one item I will be showing recursively how it goes, but I used to do that and I used to make students also work on that, because so that the algorithm will go deep into their mind. But due to shortage of time I cannot do anything, because I will be just covering the features and one level of full steps. How do you get the patterns? Because I don't have time to make you run the exercises, but at least I will explain the algorithm completely. Okay. Now, you may say, what is the reason? What is the beauty of this algorithm? See, you have seen the brute force algorithm before. Okay. When you are dealing with the brute force algorithm, it is taking a lot of time, because for each transaction you need to essentially traverse the database once. That was the brute force. Okay. But here with a priori you are able to reduce certain steps. So it all depends on how many frequent item sets are there at each and every level. Because in a priori, what is that you have done? You generated all possible combinations of k-1 frequent item sets, and from those k-1 frequent item sets that are available, you generated possible k frequent item sets, and you have pruned the items using the a priori rule. And of course, the threshold is the one you need to test. But to remove whether a pattern is, to remove a pattern, you need to check that whether it accepts the minimum support counter. Otherwise, if it doesn't satisfy that criteria of minimum support count, you will just eliminate that. Okay. So it all depends. But still, whatever it is, we have seen in our previous example, the brute force method was taking some 41 database transactions to deal with, whereas your a priori could take 13 database transactions. See, when the database is of some millions of records size, you can't just afford to have as many database scans as you like. Even the one database scan itself will be pretty expensive. So whether it is 41 or 13, even 13 could be prohibitively expensive for many databases of larger size. So in such context, what need to be done? So the real beautiful brainchild of Professor G.I.V. Han is the FP growth algorithm. Really, I like this algorithm very much. Okay? It's my very interesting topic also. Personally also like this. So there's good real logic is involved. Now, then how do you do that? How does it differ from the conventional algorithm of a priori? Here, in a priori, you are just trying to generate all possible combinations of some length k each time and eliminating using the a priori rule. Here, the bottom line is, you don't do that at all. What you will do is, with all transactions, you construct a tree. So, your transaction will be converted as a path in the tree. The bottom line is, any transaction you consider, that will be converted into a path in the tree. Now what happens here is, suppose if you consider the transactions in real time, you will have many overlaps. That is, you will be having perhaps A, B, C, D, E, A, D, E, A, B, C, A, B, C, D, A, B, C, D, E, like that. A, B, C will be repeated many times. A, B, C, D, E will be repeated many times. So, there are two possibilities. One is, you can have a longer pattern and its sub-patterns. That's one thing. And the repeated patterns. So here what happens is, each and every pattern, if any overlap is there. So what happens is, when you are constructing a path, you always consider null as the root of the tree, and whenever there is a path, if it is not existing, you will just put a path or a branch for that, and if the same path already exists, you increment the count. So whenever you are just putting a branch, you will initialize the count, and as and when some sub-pattern is there, accordingly the counts will be adjusted. So suppose you have 3 A, B, C, D, E, let us suppose. A, B, C, D is a pattern occurred 3 times. So the branch will have A, B, C, D, E, 3, 3, 3. Suppose A, B is there at another path. So that A and B counts will be added. C, D, E counts will not be added. Suppose some A, B, C comes in between. Then A, B, C counts are added. D, E will be left. So that means all paths and subpaths, they inherently converge, and the tree will be formed. So more the number of patterns, sub-patterns you have, the dense that tree will be. And if you have diversified item sets, the tree will be bushy. So ideally, if the tree contains all paths, suppose that means in the shop, if all the persons purchase, suppose there are 5 items, important 5 items. Today all the transactions of all the people is only about purchase of those 5 items only. Then you will have a single branch for the tree. Suppose if 10 members purchased, suppose 100 members purchased in your shop items A, B, C, D, E, and all the 100 purchased A, B, C, D, E only in your shop. Then it will be A with 100, B with 100, C with 100, D with 100 and E with 100. So you will have a single branch. Okay? Or if the transactions are diverse, you will have, if no 2 transactions coincide, you will be having a diversified bush. But normally it will not happen because some things coincide. As and when things coincide, the sub-patterns can be overlapped, and accordingly the counts will be adjusted. That's one thing you have to have a very clear-cut note. Now, we are considering a transactional data set over here, and we will be seeing this. Okay, here I will show how the tree is constructed. There are 2 aspects of it. One aspect is how to construct the tree. I think I have given you some hint in the class, last class, that how the tree will be constructed. Do you remember that? Right from this year and left from this year. Something like that? You know the way, sir. Okay. So I'll anyhow show. So what I did was, I'll just put the transactional thing, but if I start writing, whether time permits or not, I am worried. So depending on the time, I will write in between also, so that if I really put it on board, your understanding will be better. I know that pretty well. So to the possible extent, I will try to write also. But during that process, if I could not deliver the entire content, again, it will be a big puzzle for you. Okay? So let me have a balance between these two. See, these are 10 transactions. So here what happens is, while you are going through this process, null will be the, you need to have 2 scans of the database. You need to essentially have 2 scans. It is inevitable. In first scan, what you will do is, you will have all the single item set support count calculated. That means one item set counts you will have, and you will eliminate the infrequent item sets. Here our consideration is that the support count is 2. The support count is 2 for the things to accept as frequent items. Okay? So here you have A, B, C, D, E. So you need to have the support count of single item sets in the first round. And then you will eliminate any infrequent items are there, you will eliminate them. And having eliminated the infrequent items, you will arrange them in the descending order of their support count. So they should appear in the tree in the descending order of their support counts. Why descending order, you might question me. Yes, because the thing is, most frequent things will come from the top, and because the branching will be convenient for you. Branching will be convenient for you. But here, in this specific case, he framed the example in such a way that A will have maximum count and B will have lesser count, like he just framed, because it's for your convenience. Otherwise what happens, if suppose D is most frequent, you will have D, then A, then C, then B, like whichever it will be. Please remember that the one item sets will be arranged in the decreasing order of the support count. Why decreasing order of the support count means, near the root, suppose A has maximum support count. So first one will have 8. And then you have, that means many things are branching from that one. That is the meaning of it. So if A8 is there, the branches can be more comfortably divided. Because otherwise what happens? B is with less count, then A is there. You need to attach separate branches or something. The tree will be bit inconvenient for drawing. Here, your searching will be comfortable because all its sub-patterns will be submerged in between. So that is one very brilliant step Professor Han has taken up. It should be in the descending order of the support count. So here if you look at the support count of A is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 A's. Then it is B, C and also. I don't spend much time on that, okay? So it is in the decreasing order is A, B, C, D, E as he designed. So now, null is the of it. Now, you said, yes, what is meant by the descending order we have to write means, suppose B, C, D is the pattern, okay, obtained. Then while you are forming a path, what they say is, it should be in the descending order of the counts. Because anyhow B, C, D are in the same descending order. Let us suppose D has highest count. Then second thing is B, then C means it will be DBC instead of BCD. That means the transaction should be sorted according to the support count. Each and every transaction should be sorted according to the support count and presented here. Okay, that saves a lot of time actually. The tree will be more comfortable for appearance, and that is my higher. The better thing basically. In most of the cases, there will be certain exceptions wherein even that also need not be true, but in majority cases it works out. So here, see, null is the first one. You have the transaction AB, right? So null is here A, B are there. So A1, B1. Okay. So here you will put A and B 1, 1. Its count is. Now you read the second transaction. BCD. See, do you have any branch with BCD so far? No. So you will put another branch from null BC. You will put a pattern path there. With B is equal to 1, C is equal to 1, and D equal to 1. Okay? We will have the pattern frame like that. And then another thing is ACDE. Okay? Do you have any path with ACDE? You have AB is there, yeah, just BC something is there. See, you may say, sir, CDE is, BCD is there, but ACDE is not common there. So you have to have a path with that. See, here A, see here, A is already 1. So one more A is there subliming. So A2, its count is incremented. CDE. Okay. Now you may say, sir, here is a C, here is a C, but the thing is, this is AC, this is BC. But still, what you will do is, you will connect all the C's finally, all the B's. Suppose the B is the end point here, and B is another point here. So this B to B, some connection point we will give. Why I will tell you. When you are finding out the support counts, there will be advantages. Hence you club all B's, all C's in through pointers. See, C to C is clubbed, D to D is clubbed, E1 is here. Okay. So next is ADE. See, this is ACDE, this is ADE. That means ACDE, ADE. Now you will have, see here, ACDE is here, but ADE is another path, right? So you will have A incremented, so A becomes 3 there. D and E, another path will come here like this. Got my point? So ACDE is here, ADE is here, and the count of A is will be incremented accordingly. Okay, it becomes 3. Then next thing is, after ADE, A, B, C is there. Now please remember here, A, B, C, D you have here. Okay, but A, B, C is a sub-pattern there. So A becomes 4, B and C also the counts will be incremented. They become A4, B2, C2 by adding A, B, C. Then next is A, B, C, D is there. So here again A becomes 5, B becomes 3, C also becomes 3, and D. Okay? And A is there simply, the count will become 6. Then again ABC has come. So 7, B4, C is 3. 1 second. Otherwise, shall I draw this for your understanding? I will draw the things there otherwise, because he has read the remaining steps. Looking at, I will draw the things. Okay. Up to this you know pretty well, the third step till then. So you have null there, but after drawing only you can show that, because I need to show both. Okay. Will it be possible to show both? Okay. Then I will draw the thing, then while drawing the, because I don't have it on a piece of paper to draw. Okay. Anyway, at least you understand that better. So it is null, and you have A2 and B1. Okay. C1, B1, B1. B with 1, C with 1, and D with 1. Now, the next transaction is A, B, C, D, E, right? We have how many? 1, 2, 3 transactions we made. Up to A, B, C, D, E we made. Next is A, D, E. So how do you write A, D, E? Because C is here, so you can't submerge here. A, C, E you can't submerge here. So you have to have A, D, and E. So D with 1, here E with E with 1. But it is A, D, E again has come. So A will become 3 here now. Not my point? Next, if you read the transaction ABC. If you read ABC, then, sorry, B1, so you will extend now. So A will become 4, B will become 2, and you will have C with 1. Because ABC has come. Okay? Now, so like this, step by step you will add the strings, and then you have A, B, C, D. Okay? Once A, B, C, D is there, again you have to increment the things. A will become 5, B becomes 3, C becomes 2, and you will have D with 1. Okay? You show this and then show that. Okay? So it increments like that. Now it is simply A. So A becomes 6. Okay. A becomes 6. Same will prevail. Next comes ABC. So as ABC is there, A becomes 7, B becomes 4, C becomes 3. Okay? Right? Next is ABD. So how do you go for ABD? A, B, and you have to have D. So D will come here, D with 1. Now A becomes 8, B becomes 5, and D becomes 1. Okay? You can show this again. Okay? B, C, E. So you have B, C is common, but D is here, so you have to put something E, otherwise here with 1, and these two will be incremented. Okay? Is it clear to you? My dear friends from the colleges, is it clear to you? Because you need to have understanding very clear. Now the thing is, you attach all B's, you connect all A's, all C's. Now you come back, the numbers are tallying there, right? For the tree that is there, we show the tree there. See, if you look at null, A8, B5, C3, D1. So the tree is matching, right? For you. Only thing is I need to connect the things. It has connected C. In the picture it has connected B and B. C, 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 where it has 3 positions you have C. And you have 5 positions B is there. 3 positions E is there. Okay? Is it clear to you? How the tree is being derived? So, B's you have connected. I'll finish it anyhow. C's you have connected. D's you have connected. You have connected the D's. You have connected the E's. Okay? This is how the tree is. Now, the construction phase is over. Now we have to analyze with good clarity. Okay? I'll not straight away explain you the next step. You try to digest this procedure a little. I want to explain you how the patterns are inherently sublime. If I say FP growth is something, so from this, these are the subtrees. If I straight away go ahead with that, you will not have understanding. So I will make you acquainted with the tree here now. See, I will show you how the transactions are there and how they are being reflected here. Okay. So now you just observe carefully. What you will find is AB is there. You have AB. See, from this, if you observe the tree here, A8, B5, C3, D1. So that implies you can say there are 8 A's and A is 8 and B is 5. That implies you can have AB pattern 5 times. Just check here in the tree. AB, again AB, 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 AB. 5 times. Is it tallying? So the sub-pattern, so observing this, what you can say is, so if you analyze the data in this fashion, you will have more acquaintance with the data and next steps you can comfortably understand. So for that reason I am just making you acquainted with the data. Please listen to each and every step very carefully, because this requires good attention. Once you understand the things comfortably, you need not mug up. Things you can derive. Okay. I remember when I asked my head of the department at the BTech, finally while I was leaving the college, finished my BTech, some professor came for external exam, not the head of the department, sorry. Somehow I was impressed with him. And I asked him for, what is this? Autograph. It's not autograph. He has written, less luggage, more comfortable. So less information stored in memory and more processing will bring you a much more successful career in future. I still remember that very well. And it's true. Don't mug up things. Try to process the information. As much acquaintance you have with the system and think and analyze, your brain expands and you can go further for a good innovation. Then you will be more productive. That is the slogan today. Okay? Be employable, be more productive, be creative. How do you get creativity? Creativity you will get only by analyzing things in depth with practice. Practice means, yes, I know people practice. They don't understand, because I have seen some of my classmates during school, they used to mug up, write. Any mistake is there, mug it up for 5 times, again write. Like as if you write the poems. That doesn't serve. Okay? Remembrance is needed. And one more thing I tell you, if you analyze like this in depth, you will remember that automatically. You will obviously remember. You will not forget. I may not recollect what I studied, but I very much I can recollect what I did. If you ask me what is your MTech thesis, right now I can talk. What is your PhD thesis, right now I can talk. Because that I did. I struggled, got it. So it will be printed in my mind. But what is that I have studied 1 week back, I may not be able to repeat this. Even today also, if I do something hands-on, I can remember that and I can very comfortably express that. So your confidence levels and your authority over any topic will be obtained only through experience. And you gain experience through analysis. So analyze, practice, analyze and practice. The best, because learning programming language is different. Learning the program paradigm is different. I always focus to make people understand the programming paradigm, not the programming language. Once you are acquainted with the paradigm of the language, even there is a change in language, you can adapt it very comfortably. That is the beauty of analysis. You will be very powerful and you will be very productive if you have real hands-on. To have hands-on, you should have understanding. Suppose you are stuck anywhere, let us suppose. You try to implement that concept, you will have much more clarity. I have seen one professor saying, I could not understand, sir, how K-means is working, somebody asked. Then he said, I don't teach you anything. You take some 10 to 12 records of it, apply K-means, work out by hand, then you will understand. Implement the algorithm by hand, you will understand. So he has given, not with 5-6 things, he has given a big data set with multiple dimensions. It took for the person, because he did the program and he was stuck in between. Then his guide said, that guide is a good friend of mine, I really appreciated that. He told the student, you solve it by hand, your program, and try to learn. You struggle and learn, you will not forget. Then that fellow almost filled 120 pages and worked by hand, and then found where he has done wrong in the logic. Even I was doing the same. To build a logic as a programmer when I worked, I was an analyst. I used to take a problem, because they give the requirement document. I used to ask them some samples there, and I used to work it out by hand. Then develop the coding strategy. So suppose 10 days is the time period for developing the code. I was starting writing the program on the 7th day. But by the end of the 9th day itself, I am able to deliver the code without mistakes. Because more exercise you do, more understanding you have about data, more visualization you make about the data, that makes your logic perfect and you will be comfortable. That's why I am telling you. That's why I thought, let us analyze this data here, how these patterns and these things are there. Then the remaining logical steps you can very comfortably understand. That's my feeling. Okay. So out of practice, I am telling you. I am not telling you casually. Okay. So here A, B, it is 5 times. And now you observe A, 8, B, 5, C, 3. What does it imply? Tell me. You can have ABC pattern occurring 3 times. See here, how the ABC pattern. No. ABC is here, ABC is here, ABC is here. So it repeated thrice, right? So it's being reflected in the tree here. Fine. Then, if you look at A, C, D, E, how many times you can have A, C, D, E pattern? Only 1 time, right? Very good. See, A, C, D, E is only 1 time. How many times you can have BD? Just BD repeated. Only BD only I am asking. BD. So you will have only BD 1 time. Do you have any B and D pattern at any point of time? No, right? BD is not occurring anywhere, right? So, similarly, ACD and ABCD is only once, ABCD. So it's reflecting here. So now, in order to find out about any pattern, what is that you are doing? Whenever I say the pattern, you are going with a bottom-up approach, right? How many ABCs are there? Means you are cutting the branch up to C. From here you are going back and C3, A3 is there. So ABC contribution will be only 3 in this total pattern like that. So the same is being adopted, the bottom-up approach is adopted for finding out any kind of frequent items. Now you have generated the FP tree, fine. What for this tree? Not for playing or not for climbing, right? So, please tell me. BD, Emma, this is BCD. Idamma, yes, BD pattern is only once. I will show you BD, BCD, okay. But here the thing is in specific order. For this part is this, but you have to count, right? You have to count anywhere BD is coming. Like, see here, do you have any BD direct connection? In this case, you can have. Here B, C, D is there. In this a part can be there. You will have. That part you will see in sub-tree generation. Okay, what you asked is correct. Because here this BD is 1. Yes, what you said is correct. It will be, so you have to consider BD 1. In BCD also you will have D1. But this, when I am talking about sub-pattern thing, you will understand how. But right, what you said is perfectly right. BD is once here. Here it is one time. You forget C, B and D. So anywhere you have BD straight away coming. Nowhere, right? So you should have 2 BDs. So here in BCD, BD is there. Anywhere BD? Yes, here in 6 BD is there. In 9 BD is there. Okay. So about A, B, D. Here. Oh, okay. So ABD, BD is one thing. And in BCD, one thing. And anywhere you have ABCD, anywhere you find out the pattern. In ACD, yes, one more thing is here. In the ACDE, you have D here, right? So you have to find out all things, right? Then you will have that. Fine, you are right. You are right, very much right, okay? So ACD, one AD is there. ACD, no. BCD, ABCD, one BD will be there. You want to find out BD, right? Here B and D one pattern, and in the BCD one pattern, and another thing you have at this end, sorry, pointer recently. Yes, you have ABCD sixth one. So ABCD. In this you have BD. In this direction also BD one pattern, right? So you have that 3 times. That will come through your FP growth algorithm when you are calculating. How that comes through, I will explain. Okay. So here, yes, this is another point. You want to find out sub patterns. There sublime in between also some points are there. So your algorithm for finding out should consider only specific contributions of that specific pattern. Yes, what you said is right. Very good. So I forgot mentioning that point. Really, I appreciate for that. So you have like this that pattern calculated, and similarly ABC you want to calculate. ABC I have already shown you, right? How ABC will be calculated. So here the sub patterns and these things will match. About E also, if you want to consider, suppose how many BEs are there, you want to count, let us suppose. it is BCE. So BE is one part, right? Do you agree? And another BE contribution, do you have any BE? ఎక్కడుందమ్మా బిఈ ఎక్కడుంది ఫర్దర్ చూడండి, బిఈ ఒకటే కనిపిస్తుంది కదా, ఒకటే బిఈ కనిపిస్తుంది. బిఈ ఎక్కడెక్కడుంది, బి 10th వాళ్ళు బిఈ, ఓన్లీ వన్ బిఈ ఉంది. సో అంటే ఇది ఇన్ఫ్రీక్వెంట్ అవుతుంది మీకు, అర్థమైంది కదా. ఇక్కడ చూడండి బిఈ ఒకటే ఉంది, ఇన్ఫ్రీక్వెంట్ అవుతుంది. సో నీకు బిఈ ఎలా ఎలిమినేట్ అవుతుందో ఇప్పుడు చూపిస్తాను. బికాస్ వీఆర్ కన్సిడరింగ్ ఆల్ ఫ్రీక్వెంట్ ఐటమ్స్ జనరేటెడ్ విత్ ఈ, డిఈ, సిఈ అండ్ ఏబిఈ, ఏడిఈ, విడిఈ, అలా ఆ ప్యాటర్న్స్ అన్ని ఐ విల్ షో యూ హియర్. ఓకే, హౌ ఇట్ విల్ బి, దెన్ యూ విల్ హ్యావ్ ఎ క్లారిటీ, రైట్. B is one. But if you consider DE, how many DEs are there? DE1, another DE is here, 2. There are 2 DEs. So DE can be frequent. See, how many DEs are there here also? 2 only, if you just check. Okay, is it clear? Now your tree construction is over. Now how do you derive the frequent patterns from this? This is the real logical stuff that is important. So first thing, what we do is, we have to, let us generate all the patterns that are ending with E. So patterns that are ending with E means E is one, single one, and AE, BE, CE, DE are possible 2 combinations, and ADE, ACE, ABE, right, with all 3 combinations will be there, and ABCDE 5 pattern and 4 ones, BCDE, ACDE, all 4 combinations. So these are all possible things. Okay, so how do you get them? That is the very important aspect here. So you will have that FP growth algorithm doing this exercise for you. Next slide, తీసుకెళ్ళండి, pictures తీసుకెళ్ళండి, matter మనకు అవసరం లేదు, just please the pictures. Next. Okay, so now if you look at from the tree, how do you find out all the paths ending with E? Okay, now you look at the tree, come back to the tree. How many paths are there that are ending with E in the tree? ఈ ట్రీ ఒకటి చూసుకోండి. You have paths ending with E are 1, 2, 3. Right? So from the entire tree, you consider only the branches that are ending with E. So then what are they? A8C1D1E, A8D1E1, and B2C2E1. There are only 3 branches you consider: AC1D1E1, A8D1E1, B2C2E1. Okay, these are the only 3 paths that are ending with E. Do you agree? E1 or 2, whatever it is. There are 3 paths that are ending with E. Do you agree with me? So now you will show them there as a separate subtree. You go back there. Next. Yes, stop there. See, paths containing node E. See, A8C1D1E1, A8D1E1, B2C2E1, right? Is it right? You have 3 paths. So now if you look at, but the counts, are they exactly contributing for only ending with E? No, you have to adjust the paths, right? A8 means 8 is contribution of so many other things, right? So now, next step is you have to adjust the counts subsequently. But I will be showing how do you construct the subpaths. That part again I will come recursively how it goes like. Now if you consider only the paths that are ending with D. Come back to the original tree, sir. Sorry, I have to do this exercise 3-4 times, okay? Now you just focus on this diagram. See how many paths are there ending with E? D, A, B, C, D, A, B, D, of course A8, B5, C3, D1, A8, B5, D1. Let us not bother about the counts. A8, C1, D1, even is there, but even you cut here. A8, C1, D1 will be the thing. A8, D1 is another path, and B2, C2, D1 is one path. Okay? That means you have to consider the nodes ending with means, even though there is an extension of this with further things, you don't consider. You cut short there. Only for this even, only one A will be contributing. Do you agree with me? And for this, only one A will be contributing. So, only two A's are contributing for ending to the paths with E. Are you convinced with this? Do you agree with me? And similarly, if you can C1, D1 anyhow, this is fine. This is also 1, 1, no issue. And if you consider B2, C2, E1, what is the contribution for E? Only B1 and C1 are contributing for E. Do you agree? Apart from that, you have one more BC subpattern, so the count has increased. But what is the contribution for E alone? B1 and C1 only. Do you agree with me? So now the next step is you will consider the subtree only with the support counts related to E, adjusting the counts. Now you go to the next page wherein you have these patterns. Right. Find it. See, you zoom this. Zoom this, they will have more clarity about it. So now prefix paths ending in E, this is the one. He has repeated the picture. A, C1, D1, E1, D and E. Now, from this is the prefix paths ending in E. Now you want to find out all patterns that are ending with E. Okay? So in such case, how you will consider is you will adjust A2, C1, D1, E1. Now what he will do is, he will eliminate all E's because you are considering for E only. He knows about it. So he doesn't bother about that E. He will eliminate because lesser the tree, that is better. Because it is understood that everywhere, as if some 5 is common in 3, 4 things, you will say 5 into something like, okay. So here E is common because all are ending with E. Okay. So now if you adjust the support counts, you have A2. I have explained you why A will be 2. Right? Why A will be 2? I have explained you. So this is A2, C1, D1 and A2, D1. E is removed here and B1, C1. Okay? Sorry. B is eliminated. Why B is eliminated, I will tell you. Because the support count for this would be, I tell you, from here I will draw little bit carefully. I am erasing this tree for you for a while. Now, if you adjust the support counts, it will be A2 null, A2 C1 D1 E1, then T1 E1 B1 C1 E1. Do you agree with me? As a next step, we consider only the contributions for E and adjusting the counts accordingly. So it is A2 C1 D1 E1, A2 D1 E1, B1 C1, C1 is the bit right there, C1 there, and E1. Okay? Fine? Do you agree with me for this subtree? Now, as we are dealing with this, for patterns ending with E, as it is understood, we simply remove all the ending parts. Okay? Is it okay for you? And now we will add this, all C's. We will add all C's and all D's. Now, what is the support count here? Minimum support count is how much? Minimum support count, what did I say? 2, right, okay? See, now, if you look at this support count means all D's, all U's, if you consider, D is repeating twice here. So it is D is 2, fine. C is 2, fine. But B is coming only once. So now you ignore this. Remove the infrequent branch. So it is null C1, A2 C1, D1. Now go to the textbook. See, that's it. A2 C1 C1. You know how it is applied. Now, next step is, how do you get prefix path ending with D? Now, same diagram you take. Okay. That is ending conditional FP tree for E you have got. This is the conditional FP tree for E you have derived from prefix path. Now, if you get the conditional FP tree for E, okay, from this, what are all the possible combinations? You can have ending with DE, ending with CE, and ending with AE. You want to have all those things. Now, what are the prefix paths ending with DE now? So now if it is like this means, what does it imply? You have ACDE1, AD1, and C, simply it is coming there. Okay. Now, if you consider how do you get the prefix paths that are ending with DE? With E you have found, ending with DE means the same way you have to do. That is, you ignore with C. So if you ignore C, It is A2, C1, D1. A2 and D1. Do you agree with me? With the DE you are having it. Okay. Then you have to find out the conditional FP3 for DE. So what is the conditional FP3 for DE? Now you have to eliminate D, because for DE you are considering. C is infrequent there, so it is simply null with A2. Okay. So for DE you have null with A2 means you have two ADEs, right? Two ADE patterns can be obtained from this. Okay. Is it clear to you? Ending with DE. Because ending with E, you got the things, is it? Now, they are all one patterns. Anyhow, with ending with E, you have the clarity, no issue on that. Now, we are considering the paths that are ending with DE. So, you have derived the conditional FP3 for E. Okay? And you have eliminated infrequent things here. Right? For E, you got the this. Now if you see the frequent patterns that are ending with E and DE, I will show you. And if you కొంచెం పేజీ వెనక్కి వచ్చే టేబుల్ ఉంది కదా వెరీ ఫస్ట్ యూ కెన్ గో దేర్ కమ్ డౌన్ టు ద టేబుల్ ఇంకా వెనక్కి ఇంకా ఒక టేబుల్లో డేటా ఉంది. We have a table. The next slide. Next slide. Next slide. In the grinding. Come to the bottom. Next slide. Next. Next. Other grinding. Next. Table in the left. I can next page. Yes. See. You are finding out it is junction. See, ending with E is frequent. Okay. Now, ending with two patterns. Okay. How many are frequent? So ending with E, you know that there are three patterns ending with E. So E support count is 3. It is frequent. So you have put E there. Is it? Now next step is you have to find out two order patterns. So now you have to consider, you forget about the entire tree there. From this subtree you have to find out all two patterns means eliminate E bottom, because 3 you have put already. E as frequent item you have driven to the table. Next step is ending with DE, because if you look at what are all the possible two patterns, DE, CE, BE, AE, right? DE, CE, BE, AE. DE, CE, BE, A. Right? These are all the possible two patterns. Okay? Now, so our next step from the tree is one or two things. E is 3 you have taken out and you eliminated. That's why you have removed and you have put that subtree. Now the next part is, so I'll write down, again you need not refer again and again. DE, CE, AE only are the patterns. How they are derived? DE, CE, AE and ADE. These are the patterns, right? I'll just note down so that you need not go back to this place. Go to the other thing, sub-tree వచ్చింది కదా, ఈ tree వేసాను. Now if you look at, so you have the conditional tree, FP tree that is ending with E things you have removed. Now you have to find the pattern. So what are all the two pattern things? DE, CE, BE and AE. But here what happened? In this, while finding out your B is one support count, you have eliminated B as infrequent. That means B is infrequent with reference to E only, because you are considering only the contribution of B with reference to E. That's why you have removed B from here. You cannot remove B from other procedures. Are you able to understand? So B you have removed already. So that means BE is infrequent. Already you have understood. See, there also if you look at the entire tree in the original thing, B is infrequent, it is coming only once. Okay? So B is, that is how B is eliminated. Okay? So now, ending with E, all these patterns are there. So ending with E, we consider these patterns. D has 2 frequency count. So DE pattern will be frequent, you can understand. CE also can be frequent, you can understand. B is eliminated. A is also 2, so AE part also can be frequent, you can decide. Now what is the step you have to take? You have to construct the subtrees for DE, BE, B is not there, CE, B is not there and A, right? As B is eliminated. Are you following carefully? So now let us look at finding out the subtree for DE. So then that means as you have calculated all the paths ending with E, you have to calculate all the paths ending with D from this subtree. And what is happening? You are recursively finding out subtrees and reducing the pattern base, because from the entire tree you have found out the branches then end with E. So that means all frequent items ending with E you can calculate. Then from there you will find out all second order subtrees, means eliminate E with DE, with CE, with BE. So within that subtree only you will be further reducing for everything. And for finding out patterns ending with D, your tree is different. That just to be checked. So you have to logically visualize that very, very carefully. Okay? So from this, now how do you get things ending with DE? Then ending with DE means what is that you have to do? You have to eliminate the CS. Only you have to consider paths ending with D. Now you forget about this for a while. You remember this tree only. Okay? In this tree, you want to find out only paths ending with DE. E you have already eliminated as common thing. So you need to consider subtree that consists of these only. So if you consider the subtree that consists of these only, it will be null, A with 2, C1, P with 1. That C will come because you are considering only paths ending with D only. So these are the two things. You have to adjust the counts. Counts means yes for D1 and D1. So A2 because A is contributing for both the Ds. So no need to adjust this. C1, D. This is how the subtree will be coming. Now for this you apply the frequency item, frequent item stuff. Because that will not come, because this comes for CE. So your C count should be 1 only here. that C will not show there. Because what is your concept? I have to get for DE. So forget about E aspect. Now you consider this is the original tree. In this you want to find out only contribution of D. Getting my logic? So once this tree comes like this, now join this. C is only 1, A is 2. So C is now infrequent. So remove C. So that means CDE will not be there. You have already removed. So the third order pattern you will not have a picture. Because when you are considering second order, the third order things also will be inherently. When you are considering first order E, your second order, third order things will be inherently there. Do you agree with me? So you consider C, remove C now. That means C is not contributing for DE. This is minimum, infrequent there. So you will remove this so that tree becomes null A2 D1 and D1. So from this, what are all the patterns you can generate? This is how the tree is there. Once this tree is there, let's come to the next here. So this is the one. Do you agree? Prefix paths ending in DE. So now, how do you get the conditional tree that ends with DE? You have to eliminate D there, as if you have done previously. So it will be simply A2, null with A2. That D part you will remove. C got eliminated already. So D2. That means what you will say, you have DE is 2 support count. So DE will be a frequent pattern thing, and conditional that A2 is there, top. So A2 D2 E, you can consider that, right? The third order pattern also you can get, because A, D is 2 times. So if you remove this D, for DE it is frequent. Okay? DE is frequent, you have understood. DE you will add there as a frequent thing. CE you will calculate again, sorry. DE is frequent, you have considered. Then you have to consider the third order patterns also for this. How do you get third order pattern? You remove the D part. It is E. So you remove D part means for DE you are having augmentation. So for DE you have A2 is there. So A2 D2E it comes to. Right? So ADE also will be a frequent pattern. You don't have again some other path with B or C. B is eliminated at first level, C is eliminated at the second level. So you have only ADE third path, level path remaining. Is it clear to you? Why only ADE has come? And in this tree, ending with E, ending with DE, after that ending with ADE or BD or something. So third order pattern you will have only one. So you will make ADE as the frequent item and push it there. Now with the DE, second order patterns over, then with the DE third order. So with any order, first order pattern, possible second order one you will take. Then with that second order, what are all possible third order you will take. Then with the third order, what are all fourth order possible you will take. When you don't have third order beyond this, no question of fourth order. And fifth order is not at all there. Right? So they are being automatically eliminated. So your frequent item component at every level is pruning the branches automatically. This is one important point you have to note down. Okay? By applying support count, see here in a priori what is that? If something is infrequent, its supersets are infrequent, there's a law. So that a priori you have applied there. So you eliminated this stuff. So you can comfortably go ahead with this. So this is a subtree. Now, so with the DE you have exhausted, ADE is only one, third order is exhausted, no fourth order, no fifth order. So ending with the DE, all things are over. Do you agree? It takes time to digest, that's why I am a bit repeating. Now, if you consider, so write a program, you have to have a stack. This tree and a stack, a pointer to this thing. Because what you will do, first with the subtree, you will push onto the stack. Then you will push the thing with the D, then with something. Then you have to pop them and one by one you have to get the patterns. Okay, ante kada? And ee subtree తీసుకున్నప్పుడు దీని తాలూకు మళ్ళీ పైకి వెళ్తాయి. So you have to have that kind of operations when you are doing. It's a complex program, you have to be very, very careful. And if you really code for this and run, I am telling you, run the program. No one to beat you in programming, I tell you. Will not have anyone beat you in programming. There's a beautiful logic involved here. Do it non-recursively, don't use recursion. Manage the stack on your own, manage the memory on your own, write in C language. Then I tell you, you take even 1 month for solving this on your own. I don't really mind, but if you really take it as a challenge and do, I bet no job interview will, you will fail in no job interview in the technical. Automatically when you are sound technically, if you apply some little analysis, your expression will be there, because clarity of expression is clarity of thought. If your thought is clear, your expression will be clear. So sometimes you might forget because some other thought comes into picture, but you can immediately correct it also. Because when showing about the D, CD things, I was thinking of something for a while, I'm just an analysis. Or I skipped how to add the stuff. At that time, some thought came into my mind. I was thinking about some other proposal or something. Then immediately she pointed out. Then I have looked back and said, yes, I forgot introducing this point and corrected myself. So that means if you have clarity of thought, so that means you should not lose concentration also. By any chance, if you lose concentration, you will fumble for a while. But if you know about it, you can correct it on the spot. This is a live example. As and when just my thought process went out of on some other point for a while, when the focus went out, immediately I just forgot mentioning these things. I really appreciate it. That means you are very carefully watching. And for any teacher, if the students are alert and if they question, he will be very careful in preparing. So you should be like that. You should question the faculty without any hesitation. What is that you are doing? That makes the faculty also alert. I really appreciate it. Right. Then what I would have done is, suppose I said, oh, I would have forgotten. Then when I am coming here, I would have said, oh, I forgot telling you this point at that point of time. I had to do it. But when you point out that, if I correct it, then it gives me happiness that yes, people are listening to this. They are finding out something. So that is really an appreciable thing. I really appreciate it. Okay. Now, coming to the point here, with C, what are all the things that are there? Now we can erase these things. Your original tree ending with C. That tree is now, this is condition of P tree for E, right? Now you will have for C only. So for C only means A to C, D. Okay. Now A to C1, C1. That will be the, see, this is the diagram. The D part you will eliminate, A to C1, C1. I need not draw that here again. Okay? This you can easily understand. Now, if you consider A to C1, C1, prefix path ending in CE. So, C is a frequent thing. You can go ahead. But can you have for ACE if you want to have? Simply. If you want to have the prefix path for ACE, what will be the thing now? A1, C1 only, because the other C1 will not come into picture. A1 and C1 is infrequent, gone, no ACE. Shall I draw this again? You are saying that. No. Oh, for the first time to teach this, to understand, I did a very big exercise. I have spoiled lot of pages and I correlated with the algorithm given by Han and this. So with reference to actual algorithm, if you have explanation, that will be different. But there is a recursive algorithm, so how each step works, you really enjoy that once. Actually, I solved for remaining D, B, all those things are there. No? I solved it, but I am not able to trace the papers. If I could trace the papers, I will give them to you. It will be around, I have some 10 pages of notes I solved for each and every step on my own for rest of it. If possible, I will give you. Otherwise, you can do it on your own. You can think it and work out. It's an exercise for you. Okay. So now the thing is, your tree is null A2 C1 C1. Okay. So now you can say A2 and C is the 2. So AC is frequent. You can push into that. Now if you consider with CE, fine. CE is thing, 2 C's, E is eliminated. CE you can push there. But can you push ACE? For ACE if you want to see, for AC, you have to eliminate this portion, both C's. And null and A with 1 only. Right? C1, this will be, C will not be there. Right? So, this will be infrequent. So, eliminate. Only null is there. Not figure out. So, with the CE part, you have finished. Okay? Is it clear to you? So, with the CE and B is, Emma? You can ask me, please, don't hesitate. A2. ఏదమ్మా A2 నుంచి right, A2, this is prefix part ending in CE, not ACE. That's what I want to tell you. Because see, originally this is the tree, right? Conditional FP tree for E is there. Okay? So conditional FP tree for E is there. It is A2 C1 D1, A2 D1 and simply C1. Okay? For all the things is the end point. See from here. Right? Now with this you have to find out all 2 patterns that come with end with E. What are all the possible 2 patterns that end with E? AE, BE, CE, D. But B is automatically eliminated there. So that means with BE 2 pattern itself is infrequent. So BE, BCE, BDE, none of them will come in. And all the patterns that contain 3 or 4 or 5, anything with B that end with E will not be there. Okay, is it clear to you? Huh? Now the thing is, so this is the conditional FP tree for E. Now from this you have to calculate the patterns with DE. Okay, that means second 2 order patterns. DE, once CE also have to find out. So for C we will come later. So for DE, what are the patterns here? So that's why you have eliminated C's there. Only thing that is contributing is A2 C1 D1, A2 D1. Why C1? Because for DE that is not contributing C. You have removed that. So this is the one. prefixes ending in D. Okay. Now here, if you consider D and D, there is 2. But here, A, C, D, there is 1. It is only 1. Because D is only 1. Because D is only, C is only 1, this becomes infrequent. That means this is the path contributing for CDE, right? So, C is infrequent as far as ending with D is concerned. So, that's why you have removed C. So, it is A2 and D2 only. So, then AD is a frequent item, you can write that. I'm sorry, not AD. DE is a frequent item, you can write that. But can CDE write? No. Because what is your aim? You have to find out frequent patterns with D. See, 2 items are these. So once you are calculating for DE, you have to calculate for ADE, BDE and CDE. Do you agree? And the other 4 patterns will be ABDE, right? You will have those things. Now from the tree, what is that? You have to calculate from E. I think if I put it as a tree, you will understand better. Okay. From E, how to calculate for AE, BE, CE and DE. From DE I have to calculate for ADE, BDE, CDE. The 4th level I don't show you. Anyhow, you don't have it for this. అందులో ఫ్రీక్వెంట్ ప్యాటర్న్స్ అనేసరికి ఫస్ట్ ఆర్డర్ ఈ తోటి అంటే ఇంకో ట్రీ విత్ డి వస్తుంది, ఇంకో ట్రీ విత్ సి వస్తుంది, రైట్? సో ఈ వస్తే ఈతో ఎండ్ ఏఈ బిఈ సిఈ డిఈ. డూ యూ అగ్రీ విత్ మీ? ఇప్పుడు ఈ 3 అలా ఉంచి ఈతో ఉన్న ముందర చూసాం. ఈతో 3 ఉంది కాబట్టి వెళ్ళిపోయారు. ఈతో 3 ఉన్న తర్వాత సెకండ్ ఆర్డర్ ఎన్ని ఉన్నాయి? ఏఈ బిఈ సిఈ డిఈ ఉన్నాయి. సరే, డి నుంచి మొదలడా అని వచ్చాం. డి నుంచి వచ్చి డిఈ ఫ్రీక్వెంటా కాదా చెక్ చేయాలి. తర్వాత దీని తాలూకు థర్డ్ ఆర్డర్ ఏమైనా ఫ్రీక్వెంటా కదా చెక్ చేయాలి. ఇందులో థర్డ్ ఆర్డర్ ఏమైనా ఫ్రీక్వెంటా, దాని 4th ఆర్డర్ ఫ్రీక్వెంటా కదా చెక్ చేయాలి. తర్వాత 5th ఆర్డర్కి వస్తాం. అవునా? ఆర్ యూ కన్విన్స్డ్ టు దిస్ ఎక్స్టెంట్? సో నౌ వాట్ ఐఎమ్ డూయింగ్ ఈస్, హియర్ ఐ హ్యావ్ షోన్ యూ. నౌ యూ కమ్ టు ద ట్రీ. హియర్ దిస్ ఇస్ ద ట్రీ దట్ ఈస్ ఎండింగ్ విత్ ఈ. ఇప్పుడు ఎండింగ్ విత్ ఈ వచ్చిన తర్వాత ఏం చేసావు? ఇప్పుడు తీసుకోవాల్సింది డిఈ కాబట్టి ఇందులో డితో ఎండ్ అయ్యి ముందర ఎఫ్పి కండిషన్ ఎఫ్పి ట్రీ ఫర్ ఈ తెచ్చావు ఇందులోంచి. ఓకే, దిస్ యూ హ్యావ్ కమ్. సో ఈకి వచ్చే ఫ్రీక్వెన్సీ ఈ 3 కాబట్టి బేసిస్ అవు. ఇంకా ఈ వచ్చాక ఈతో రావాల్సిన ఏఈ బిఈ సిఈ డిఈ అది తీసుకోవడానికి ఈ ట్రీ బేసిస్గా తీసుకోవాలి. ఇది తీసుకున్నప్పుడు ఇందులో ఏమనుకున్నావు? ఇప్పుడు డిఈ తీసుకున్నాను, ఇక్కడి నుంచి మొదలెట్టాం. తర్వాత సిఈ, తర్వాత బిఈ, ఏఈ రావాలి 1 by 1. ఓకే, ఇప్పుడు డిఈ తీసుకున్నావు. డిఈ తీసుకోవాలంటే ఏం చేయాలి నువ్వు? ఇందాక ఒరిజినల్ ట్రీలో ఓన్లీ ఈ కావాలంటే ఈ వచ్చి పార్ట్స్ మాత్రమే ఉన్న మొక్క తీసుకుని మొత్తం ట్రీ ఎలా వదిలేసావో ఫాలో కేర్ఫుల్లీ. ఇది ఒరిజినల్ ట్రీ అనుకొని, ఇది ట్రీ అనుకొని, బికాస్ ఈ మొక్క ఏంటిది? దిస్ ఈస్ గివింగ్ యూ ఓన్లీ ది కండిషనల్ ఎఫ్పి ట్రీ ఫర్ ఈ. ఈ మొక్కని ఇది వదిలేసి ఫ్రీక్వెన్సీ కౌంట్స్ దీని ప్రకారం అడ్జస్ట్ చేసి ఇది ట్రీ అనుకుని, ఇది ఇలాంటి ట్రీ అనుకుని దీనికి సంబంధించి డిఈ కావాలనుక ఓన్లీ డికి సంబంధించింది సివి వదిలేసి డికి కంట్రిబ్యూట్ మాత్రమే చేసి సబ్ పీస్, అంటే దీన్ని ఎలా సబ్ పీసెస్ తీసుకుంటే అలా తీసుకోవాలి. అలా తీసుకుంటే ఏమొస్తుంది? ఏసిడి వస్తుంది. ఓకే, ఏ టు డి వస్తుంది బ్రాంచ్. అవునా? అర్థమైంది కదా? అది వస్తే ఇక్కడ సి ఫ్రీక్వెన్సీ అంతా 1, అంటే సికి ఇంకోటి కలిపేది లేదు. అందుకని సి ఇన్ఫ్రీక్వెంట్ అని సి తీసేస్తాం. తీసేస్తే అప్పుడు ఏమవుతుంది? ఏ టు డి2 కింద వస్తుంది ట్రీ. అవునమ్మా? null వచ్చి we will have అది ఉంచండి, నా దగ్గర డయాగ్రామ్ లేదు కదా. ఓకే, A2 and D2, it will come like this. ఒప్పుకున్నా కదా? If it is A2 and D2, then you can say that AD is frequent. Okay, AD is frequent and this tau, DE is frequent and this time, sorry, you will say that DE is frequent because ఈ D2 నుంచి ఏంటి వచ్చింది, E కదా, ఆటోమేటిక్ గా ఫస్ట్ రౌండ్ తీస్తావు కదా. సో D2 ఉంది, E ఆటోమేటిక్ గా 2 ఉంది. సో యూ విల్ సే దట్ DE is frequent, DE frequent అని వేస్తాం. వేసిన తర్వాత నెక్స్ట్ స్టెప్ ఏం చేయాలి, థర్డ్ ఆర్డర్ ఏంటి, ADE BDE CDE రావాల్సింది. కానీ ఇందులో Bతో ఏం లేదు బికాస్ ఎలిమినేట్ అయిపోయింది ఆల్రెడీ. Cతో కూడా ఏం లేదు, ఎలిమినేట్ అయిపోయింది C రెండో రౌండ్ లో. ఇంకా మిగిలింది ఏంటి, ఏనే. ఇక్కడ A2 D2 ఉంది అంటే కింద E ఆల్రెడీ ఉంది అని చేత ADE ఈజ్ ఆల్సో ఫ్రీక్వెంట్. అంటే అప్పుడు D తీసేస్తాం మళ్ళీ ట్రీ గీసేటప్పుడు, అవునా? ఇప్పుడు DEతో ఎండ్ అయిపోతుంది, ఇందాక Eతో ఎండ్ అయిపోతుంది, ఇప్పుడు DEతో ఎండ్ అయిపోతుంది. అది తీసేస్తే ఓన్లీ నల్ అండ్ A2 మిగిలింది అన్నమాట. అర్థమైందా? నల్ అండ్ A2 మిగిలిందంటే నువ్వు కట్ చేసిన పార్ట్ DE కనుక A2 D2 E2 అంటే ADE ఈజ్ ఆల్సో ఫ్రీక్వెంట్. సో ADEని ఇక్కడే పంపిస్తాం. ఇస్ ఇట్ క్లియర్ టు యూ? ఏమా ఓకేనా? మొహమాటం అర్థం కాకపోతే మళ్ళీ ఏం ప్రాబ్లం లేదు. కింద తీసుకొస్తాను, ఇక్కడి నుంచి వస్తున్నాను నేను. అంటే ఇది ట్రీ ఉంది, ఇప్పుడు DEతో సంబంధించి పని అయిపోయింది. ఓకే, ఇప్పుడు DEతో పని అయిపోయాక ఇప్పుడు నీకు కావాల్సింది ఏంటి, ఇప్పుడు ట్రీలో ఇక్కడికి వస్తావు, CEతో కావాలి. ఓకే, అప్పుడు ఇది వస్తుంది. అందుకని నేను ఇక్కడి నుంచి ట్రీలో వేసి చూపించాను నీకు. నౌ యూ వాంట్ టు ఆస్క్ అబౌట్ ఇట్, రైట్? ఇప్పుడు యూ హ్యావ్ దిస్ ట్రీ, రైట్? You have this tree. This is your original tree. With the D ఉన్న పార్ట్ ఇందాక ఈది ఎలా ఉందో Dతో తీసాం. ఇప్పుడు ఇందులో Cతో ఎండింగ్ చేయాలంటే ఏమొచ్చింది, ట్రీ D వదిలేసి ఓన్లీ ఎండింగ్ విత్ C అంటే యువర్ A2 C1 క్లబ్డ్. ఒప్పుకున్నావా? ఆర్ యూ కన్విన్స్డ్ విత్ దిస్? చెప్పు. ఇక్కడ ఏంటంటే నీకు A2 C1, ఎస్, అది నీకు టెక్స్ట్ బుక్ లో తప్పుపడింది. రైట్, ఐ విల్ కరెక్ట్. ఎస్, టెక్స్ట్ బుక్ లో తప్పుపడింది, ఎందుకంటే నేను నా బుక్ లో కరెక్ట్ చేశాను. రైట్, యు ఆర్ వెరీ మచ్ రైట్. ఓకే, సో దట్ కంట్రిబ్యూషన్ ఈజ్ 1 ఓన్లీ. ఎస్, ఇట్ ఈస్ రాంగ్. ఓకే, నా దగ్గర టెక్స్ట్ బుక్ చూడు, ఐ హ్యావ్ కరెక్టెడ్ ఇట్ అండ్ ఐ హ్యావ్ గివెన్ ఇట్. ఓకే, రైట్, వెరీ గుడ్, ఐ అప్రిషియేట్ యూ. సో అందుకే మీకు అక్కడ A2 ఇది ఉంటే నీకు మళ్ళీ వస్తుంది. ఇక్కడ A విల్ బికమ్ 1 బికాస్ ది కంట్రిబ్యూషన్ ఈస్ A is 1. అందుకే ACE విల్ నాట్ కమ్ ఇంటూ పిక్చర్ దేర్. ఓకే, అండ్ C is 1 and C1. Okay, అయితే now what happens here, because A is infrequent, that will go off and you will have tree as null and C2. C2 means C ending with E kada, C2 E2. So CE frequent అవుతుంది. A ఇంకేం లేదు కాబట్టి ACE కానీ BCE కానీ DCE కానీ రావు. You are very much right. I really appreciate you people today. Okay, so it will not come into picture. So it is being eliminated. Okay, good. So it becomes C2 only. Now B is already eliminated, so no question of B. Next is AE. So with A, if you look at, simply it is A2 only. Okay, A తో అంటే only A is 2. So only AE will be there. no other parts. So AE is going there as frequent item, no other 3 order, 4 order, anything. When 3 order is not there, 4 order will not be there. Ardhamavutundha kada? Yes, it is wrong. It should be 1. Okay. Right? So that is how, till the thing is exhausted, you will proceed. Okay? Good. మీ ఇద్దరికి మంచి చాక్లెట్లు ఇవ్వాలి. ఓకే, యు ఆర్ వెరీ అలర్ట్. సపోజ్ నీకు అక్కడ A2 ఉందనుకో ఫ్రీక్వెన్సీ, అప్పుడు ACE ప్యాటర్న్ ఆల్సో విల్ బి దేర్. ఓకే, ఇట్స్ ఏ మిస్టేక్ ఇన్ ద టెక్స్ట్ బుక్. సో దట్ ఈస్ హౌ యూ విల్ ఫైండ్ అవుట్ ద ప్యాటర్న్స్. ఓకే, యాక్చువల్లీ లాస్ట్ టైమ్ ఐ థాట్ ఆఫ్ రైటింగ్ టు ది ఆథర్ ఆల్సో, బట్ somehow I forgot that. Okay, it's obviously a mistake in that. So I thank you very much for your patient listening and alertness also. I really appreciate it today. Now if you analyze the stuff, the difference between a preview and this, because why I am telling you is, for the sake of A2, when I was reading this book for the first time, I struggled a lot really. It took some time for me to analyze that. Probably a couple of hours I have spent. Did I go wrong at any point of time? Like, okay. So now this is about the FP growth algorithm. If you are interested, you can refer to Han and Camber. Again, in Han and Camber, I think in the first edition of the textbook there was a mistake. Printing mistake is there, but in second and third editions it is corrected. Even that has killed me for one more day. Okay, so almost when I want to debug this program here and club with Han and this, almost I ended up spending 1 week for the first time to resolve these issues. Okay, so but I enjoyed it even though I struggled. So, but I never tried to code for this because somehow I was busy with many other activities. So if really time were permitted, I would like to code this basically, but I don't know when I will have a chance to do this. But I really appreciate if someone of you really work for this, code it, and if you code it, your experiences can be presented. Because in my observation, because when I coded for a tree called KD tree, I coded for a KD tree. I did it in a non-recursive way, and the non-recursive implementation, because I maintained a stack and all on my own, I had to allocate the memory as and when the job is over. I had to free the memory. So in such way, I maintained a stack, and each is a pointer to the tree nodes at one particular level. Like, so when I coded for that, I could get at least 40% reduction in the execution time between recursive and non-recursive procedures. Because if you use recursion, the stack need to be maintained by the system, and system has to struggle a lot because it's a generic code. Whereas if you code for that, you know where to allocate memory and where to deallocate memory. So obviously a non-recursive procedure will reduce your execution time and memory thing. But coding is difficult for you, but if you understand the process, it is really good. So I always advise you, because in my career also, by using non-recursive methods for certain standard things, I could get good performance obtained in many of the server-side programs. And in server-side programs, execution time is a very important issue. So this